All right, welcome back, Stats 111. Here's 8.2 notes, page 12. The National Center of Educational Statistics reported that the mean number of instructional computers per public school nationwide was 124. The standard deviation, 49. Suppose that we take a sample of 75 public schools. No distribution shape was given in the question. Does it matter? Why or why not? Since we're taking a sample space bigger than 30, it doesn't matter. And we can pretend that it's normal because it's approximately normal. With that big sample space, we can assume normality. Here we go. The probability that the mean number of instructional computers is less than 100. A picture of this event. The average, 124. We want less than 100. 100's to the left of that. That's what we need to find. You guys can do this with the z-score table. First, you'd have to calculate the z value and then look it up on the table, or we can just use our calculators. For the standard deviation, the original standard deviation is 49. So what is our standard deviation of the means? That is 49 divided by the square root of 75. That's our first calculation here. 49 divided by the square root of 75. Convert it to a decimal here. Now we're ready to plug those numbers into our calculator. We want the area to the left of 100. Here it comes. Shift data, or get in your distribution menu, normal CDF, and we want the average this time is 124 computers. The new standard deviation, 5.6580. The lower bound is going to tail off to negative infinity, so we leave that the way it is, or you can use like negative 1,000. That would be sufficient too. The upper bound, 100. Calculate that one. That is not very likely. If we scooch the decimal place over 2 spots, the percentage would be less than 1,000th of a percent. So, not too likely at all. We want to solve again, I think, with the same things. Here we go. Let's try this one. The probability that the mean number of instructional computers is between 100 and 120. I'll have a picture of this. Always mark the average first. 120, that's a little bit to the left. 100, that's a little further to the left. So we want to find the probability that you live in that particular zone. Luckily for us, we don't have to compute this new standard deviation value. We just have to plug them into our calculators. Here we go. Hopefully you guys can see this okay. Shift data, get into the distribution menu, normal CDF. The average is the same. The standard deviation is still the same. That's kind of nice. But our new boundaries are 100 and 120, the lower and the upper. Let's see what's the probability of picking a school out that's in that zone. 23.97%, 23.98%. Nice. Last problem. What's the probability that the mean number of instructional computers is more than 150? Here's a picture. We put the average right there at the average, 124. 150 up here. It's going to be small too, isn't it? Not very many schools will have within that number. So we use the same standard deviation. blah, blah, blah. And here it comes. 124, same standard deviation. This time, the lower bound is our 150, and our upper bound is positive infinity. That's sufficient. Okay. Remember, when you put negative infinity, don't forget your negative symbol. Here we go. Boom. Calculate it. Tiny, just as we suspected. And that is it. That finishes out notes for 8.1 rather. I hope that's been helpful. Good luck doing your homework. We have the homework is due Monday night. That's, I think, April 13th, and the test will be April 14th. Talk to you soon.